All right, we're starting 9.1, surface area and volume of prisms. Throughout this unit, we're going to be looking at surface area and volume of many different shapes and things, but today we're just going to focus on prisms. Okay, a prism is a three-dimensional solid with two bases that lie in parallel planes. So you'll see that this base and this base are in parallel planes, and they have vertices or corners that are connected with line segments called edges. Every prism is made up of bases and lateral faces. So lateral faces are these faces that you can see that go around the shape. Vertices, base edges, so that would be these things, and then lateral edges are these guys right here. Okay, so take a moment and see if you can name all the vertices, bases, base edges, and lateral faces, and then check back. Okay, so here we have the vertices. So the vertices are our corners. So we label those by the points that they're at. So that would be A, B, C for the top base, and then A prime, B prime, and C prime. So we have 6 total vertices, these 3 and these 3. Now the bases, we usually name them by what shape they are. So the base is what it stands on. So this is what it's standing on. It's a triangle. So we have triangle A prime, B prime, and C prime, as well as triangle A, B, C for the top. When we're talking about edges, we're looking at all the edges that connect. So base edges are going to be the top ones and the bottom ones. So base edges are going to be AB. Remember what we talk about with line segments, they end. Then we have BC, and then we have AC. We also have 3 more at the bottom, so that would be A prime, B prime with a line segment, B prime, C prime, and A prime, C prime. Don't forget those lines on top. Lateral edges are going to be the A prime, B prime, and C prime. When we're talking about the lateral faces, this is one of them, for example. That's a face. So I could say quadrilateral A, C, C prime, A prime. You have to go in the order. So if I start here and I go A, C, then C to C prime, and then to A prime, and then I go back up to A. Another face is back here. So we can write that one as quadrilateral A, B, B prime, A prime. And then last but not least, we have this guy over here. So that would be our quadrilateral B, C, C prime, B prime. Okay, so looking at these here, we have a right prism with lateral faces being rectangles. What that means is that it forms 90-degree angles to the base. So our lateral edges, we're using vocabulary here, our lateral edges are perpendicular to the base. On the other side, we have oblique prism. Oblique just means slanted. So it means like it's the Leaning Tower of Pisa. It's slanted a little bit, but we do know that our bases are still parallel to each other. So our lateral edges, again using vocabulary, if you don't know what that means, look back in your notes, are going to be oblique to the base. So just like with a right triangle, how it makes that right angle, all of those edges are perpendicular to that base. Okay, name each of these prisms. Go ahead and take a second and see if you can come up with what you think the names of these are, and then check back. Okay, so now I see that I have the lateral edges to the first one are perpendicular to the base, and the base is a hexagon. And I know that because if I count 1, 2, 3, 4, 5, 6, I have 6 sides, so it makes it a hexagon, so we call it a right hexagonal prism. Now for this one, it shows that the lateral edges are not perpendicular. Up here we saw that we had right angles, and here we do not. And the base is a pentagon because 1, 2, 3, 4, 5, so it is an oblique pentagonal prism. Last but not least, we know that our lateral edges are perpendicular to the base, and that our base is an equilateral triangle. So we get a right equilateral triangular prism. All right, so area of a prism. So here the lateral area of a prism is the sum of the areas of all the lateral faces. So this is where we have some vocabulary. So here we see that we have this guy here that we have to add to this guy here and to this guy here. You could apply this to figuring out how much paper you needed to wrap around something, excluding the bases, and so forth. We can also think of it as finding out what the perimeter is of the base and then multiplying it by the height, because it's almost as if there's however much the height is, however many of those triangles just sitting in here. All right, so that would be figuring out the area, because we're just dealing with the outside. We're not dealing with anything on the inside. So go ahead and see if you can figure this one out on your own. Then check back with us. Okay, so here what we see is that we have a pentagon, and I have a regular pentagon. They're equilateral pentagons, so they're all the same length here. So if these are all 3, then so are these. We know that they're 4 inches tall. So to find the area of one of our rectangles, we multiply 3 times 4. And so that gives us 12 inches. Now I know that I have actually 5 of those, so my total area lateral area is going to be 60 inches squared. Okay, so for any prism, the total area is the sum of the lateral areas of the base and the areas of the bases. So to find the total area, or what we call as the surface area, so I'm going to use the words surface area from here on out, that we want to figure out the area of each of our lateral faces and the bases as well. So the first thing I want to find out, so I usually write it as surface area, SA, I usually write it as 2 bases plus we have 3 faces. Now in this case, our faces are different. We have this face that's a 15 by 8. So one face we have, so 15 times 8. So our 3 faces equal 15 times 8 plus. Then we see that we have this guy here, and that's a 14 by 8. And then at the very end, we see this guy over here, and so that's a 13 by 8. So when I add all those up, I'll see what my faces add up to. And so if I add up all of that, we have to add up our bases as well. So now looking at our bases, I should see this is one base, which is equal to this base down here. Now we know how to find the area of a base that's a scalene triangle, and we use Huron's formula. So the area of my triangle is, we have to find our semi-perimeter, and we know that our semi-perimeter in this case is 21. If I add up 13 plus 15 plus 14 and then divide it in half, I get 21. So 21 times the difference of 21 minus 15 is 6, 21 minus 14 is 7, and 21 minus 13 is 8. So when I take the square root after multiplying all of those together, I see that the area of my triangle is 84 inches squared. But that's just one triangle. So to find my surface area, I have to take 2 times the area of my base, and then I have to add in all that extra stuff. So when I add in all of that, I get 120 when I multiply them out, plus 112, plus 104. So that tells me that my surface area is 504 inches squared. Why don't you take a minute and figure out if you can see what the lateral area and the surface area of this regular hexagonal prism. You're going to have to bring in some of your knowledge about hexagons and how to figure out the area of a hexagon. Okay, so I first found my lateral area right over here. I found the area of one of my faces. Since it's regular, that's why we can do this. I have my base times height, 4 times 10 is 40, and I have 6 of those as I go all the way around my prism. So I have a lateral area of 240 inches squared. So now I need to find the area of one hexagon. And the area of one hexagon we can find out over here. So if I drop the height down, I have this. I recreated it over here. We know that this is an equilateral triangle because it's a hexagon and it's 60, 60, 60. So that allows me to use special right triangles to find my apothem to be 2 root 3. I plug it in, canceled the 1/2 and the 2, and I get 24 root 3. Problem is, when we find the surface area, we have to have 2 of those because I have one down here and one up here. And then I can add in the surface area there of the lateral area. So I get to 240 plus 48 root 3 inches squared, or 323.138 inches squared. Go ahead and see if you can try this one on your own. Okay, so we see that the surface area of the box is equal to 2 of the area of my bases plus 4 times the area of the faces. So I know that the area of the face is this guy here, so 8 times x. And then the area of my base is x times x. So when I plug it in, I know my surface area is 210. I know what 2b is. That's just 2x squared. And then 4f, so that's 4 times 8x or 32x. So I see that I have a quadratic. I have to set it equal to 0. I go ahead and move over that 210. Now I notice that all of my terms are even, so I divide them all by 2 to give me something a little bit easier to work with. And I end up factoring it with x plus 21 and x minus 5. So that gives me x equals negative 21 and x equals 5. We can't have a negative side length, so the only possibility here would be that x is equal to 5. All right, volume of a prism. So volume is how much space something takes up. So in this case, if we have our rectangular prism, we know this formula very well. Length times width equals length times width times height equals our volume. We can think of that almost as many infinite pieces of paper or slats or anything that are filling up this box. So it's the area of this shaded in as tall as it is. So it's one big cube type thing. All right. So if we have a right prism, so right prism is important. It has to be a 90-degree angle where the lateral edges meet up with the base. We can really just find the area of the base and multiply it by the height. So here we would find the area here of this hexagon and then multiply it by 10, which is the height. Now in an earlier problem, we already found out what the area of my hexagon was. And so look that up in your notes and you'll see that it's 24 root 3 inches squared. But I want to find volume. So I have the area of this guy. I just need to multiply that and have infinitely many, right? I really have 10 tall that'll all fit in here. So I'm going to have my volume be the area of my base times the height. So my volume is 240 root 3 inches cubed. It's very important that we remember our units here are cubed. So they're raised to the 3rd power. Or we could think of our volume as 415.692 centimeters, not centimeters, inches cubed. So keep in mind, area, units, squared. Volume, units, cubed. Okay, last example. Sarah's having a concrete driveway poured at her house. The section to be poured is rectangular, measuring 12 feet by 40 feet and is 4 inches deep. How many cubic yards of concrete are needed? So for this kind of problem, always draw a diagram. Doesn't matter how pretty or perfect your diagram looks. It's just important that you draw one. So I know that it's 4 inches deep, but these are both feet and this is inches. So I need to convert that guy to feet. So 4 inches times 1 foot has 12 inches. This is where your stoichiometry is going to come into play. Inches cancel, and 4 over 12 is our feet. So 1/3 of a foot is how deep it is. So that's what's going to be right here, 1/3 of a foot. We know that it's 12 feet wide by 40 feet long. Now what I want to do is figure out volume. So we know that our volume is base times width times height, or really length. Let's use length instead of base. So length times width times height. So my volume is length is 40, width is 12, and my height is 1/3. When I multiply this out, I get my volume to be 160 feet cubed. Now let's go back to the question. It asked for cubic yards. So we have to convert this again to change the feet into yards. So what I do is I think, okay, 160 feet cubed, how many yards is that? Well, in 1 yard, we have 3 feet. So we have to cube it. So that tells me that 1, so we're multiplying here, it's not equaling 1, so we raise 1 to the 3rd, well that's 1, and then yards cubed over 3 cubed is 27 feet cubed. So just like with numbers, you're going to cube everything inside of that. So that tells me that my feet cubed cancel, so I'm left with 160 over 27 yards cubed. So if we plug that in, nothing can reduce it, so we'll see that we have about how many cubic yards? We need about 5.926 cubic yards.